determine the integral from 0 to 1 over 2 of x to the power of 4 into 1 minus 2x all to the power of 3 dx. The general form for the beta function is beta of m and n is the integral from 0 to 1, okay, of x to the power of m minus 1 into 1 minus x to the power of n minus 1 dx. This integral is not exactly in this form, so we have to modify the integral. This is how we start. If you look at this bracket, I have 1 minus x, but what do I have here? 1 minus 2x. So I will say let this 2x be equal to a new variable such as u. Now, if I make x the subject of the formula, x will be equal to u over 2. And if I differentiate u with respect to x from here, it will be equal to differentiate this, that will be 2. So cross multiplying will lead me to du equal to 2 dx. And if I make dx the subject of the formula, dx is equal to du over 2. Alright. Now, this limit is from 0 to 1 over 2, right? So when x is equal to 0, what is u? If I plug in 0 here, that will be 0, right? So when x is 0, u is 0. When x is equal to 1 over 2, what will be u? Put 1 over 2 here. That's 2 times 1 over 2. That will give me 1. So the limit of integration for the new integral will be from 0 to 1 also, which is in this form. So I'm going to write this integral as the integral from u equal to 0 to u equal to 1. X is now u over 2. U over 2 to the power of 4. To the power of 4. Okay, I'm going to write it, just follow me. Into 1 minus, in place of 2x, I'll be writing u. Raised to the power of 3. In place of dx, I'll be writing du over 2. Okay, so I want to write this integral again very clearly. The integral from 0 to 1 of u over 2 to the power of 4 into 1 minus u to the power of 3 du over 2. And so this is equal to, let's simplify this. The integral from 0 to 1, that will be u to the power of 4 over 2 to the power of 4 is 16, okay, into 1 minus u to the power of 3 du over 2. 2 times 16 is 32. So I can bring that out, 1 over 32 into the integral from 0 to 1 of u to the power of 4 into 1 minus u to the power of 3 du. So this integral is in this form. Alright, let's see. To write that integral exactly in the format of the beta function, this is how we're going to write it. 1 over 32 is outside, so this is times. To write 4 as something minus 1 will actually be 5 minus 1, right? So we have the integral from 0 to 1 of u to the power of 5 minus 1, that will give me 4, into 1 minus u to the power of 4 minus 1, that will give me 3 du. If this is beta of m and n, because we have m here and we have n here, so m here is 5, n here is 4. It means that this is beta of 5 and 4. So we have 1 over 32 times beta of 5 and 4. That's it. So we now have to evaluate beta of 5 and 4. This is 1 over 32 times, I gave you a formula in the previous video on beta function, and I said that beta of m and n is simply m minus 1 factorial times n minus 1 factorial divided by m plus n minus 1 factorial. And I said this is also equal to gamma of m times gamma of n divided by gamma of the sum of m and n. So whichever one I choose to use, I can solve. Let me use this. So beta of 5 and 4 will be equal to 5 minus 1 factorial times 4 minus 1 factorial divided by 5 plus 4 minus 1, 5 plus 4 minus 1 factorial. So this is 1 over 32 times 4 factorial times 3 factorial divided by 5 plus 4 is 9. 9 minus 8. 9 minus 1 is 8. So we have 8 factorial. Okay. I think you will have to use your calculator to do this. If you simplify with a calculator, you will get 1 over 8,960. Verify. 4 factorial times 3 factorial divided by 8 factorial times 32, you will get this.